Welcome to this episode of Robots in Depth. Today I'm here with Lars Dalgaard from the Danish Technological Institute, which is combined research and applied sciences institution. So we're going to talk about the projects they do there, but let's start in the beginning. How did you get into robotics? Why are you doing robotics right now?
Well, it was a bit of a coincidence, actually. I started a degree at university here back in the 90s, which was actually more focused on creating an engineering degree with higher level university on math, physics, and computer science. And that slowly evolved, basically, as the years went by, into robotics, as we got more and more courses that were relating to robotics. And this was mainly due to a huge effort by the then steel shipyard here that together with university started up the Linnaeus Center for Applied Mathematics, looking into welding robotics. And as more and more people got into that, we got more teachers that could teach these courses. And as the degree I was in was quite, fixed, we didn't have much freedom in choosing courses. So you could basically choose a robotics track or a robotics track. So I chose a robotics track.
Oh,
that's a surprise. And combined with summer courses where students would go and rebuild remote control cars, introduce small racing cars, simple LEDs and line following. It kind of took speed, and I ended up doing my master thesis at the end of the 90s in a modular robot, actually, for educational purposes. It was used in some other teaching projects.
Cool.
For students.
Getting robots in the hands of students of all ages is just fundamental.
Yeah.
So you started that way, and then you went on to work permanently here at the institute?
Oh no, that was not for a lot of years.
Okay, so let's follow the story along.
Full story. Just before finishing my final thesis, I was approached by a small two-people company doing big mobile robots for outdoor nursery gardens. It was a company called Manox, and that was back in 2000, I think. And they were looking for replacing one of the owners at the time for a worker, and I got the position. So we were two guys that were basically building huge 200-kilo mobile robots that could transport 200 potted plants from a potting facility and then place them on the ground. That was the concept anyway.
What kind of plants were they?
Everything, and that was turned out to be quite a challenge because this particular gardener we were working for, we actually had a customer at the time, had about 200 different types. And the principle we had for putting plants on the ground was relying on a plane that was slightly tilted. And the higher the plant, the higher the risk that they would tip over. So we learned the hard way about design requirements. We did a lot of good work, and we made a lot of progress. I think we were fighting a lot, changing requirements, and we were not old enough, had not enough experience to actually, draw a line somewhere and say, no, we can't do that. And learned the hard way that you shouldn't solve mechanical hardware problems in software. And that's what we ended up doing. So in essence, the company didn't last. We were almost there, but only almost, not good enough.
And the robotics is challenging from that perspective, that almost a robot is no robot.
Exactly.
To a larger degree, I think that's true for robotics than it is for software. A software product can be valuable even though it isn't complete, but a robot has a more challenging time doing that.
Yes, exactly.
So then you went on from that company?
I was hired as a research assistant at university, working on an European-funded project called Hydra, where we were building self-reconfigurable modular robots.
Which is my pet field, I just love it.
Called the Atron modules, small blue ones, where I also worked closely with Esben from Universal Robots and Kasper Støy, who's now at IT University in Copenhagen. So I was doing that for, I think, a year and a half. And then I went on to be a teacher at the engineering college here in Odense as well, teaching automation and robotics for a couple of years. And then for a time, I'd had this gut feeling, basically, that there's something wrong with robotics, because you see a lot of industrial manipulators out there, but you don't really see any real new types of robots on the market. You see a lot in the university test grounds in the labs, but they never really get out there. We tried with the gardening, or the mobile robots in gardening, that it didn't really work. Atron modules was clearly a research project, so there was a barrier somewhere. And I started putting together the pieces a little bit, and of how I saw the world and what was wrong with it. And part of it was that people, especially in robotics, failed to have a system level perspective on robotics. They saw the technology, but not how to put it to use. So together with a professor that was at university and still is, John Hallam, I cooked up a PhD proposal for basically looking at system level design of robotic systems to see how can we actually take the technology and move it into the market, what is required. And I applied and I actually got the funding for it, but only half of it. So university at the time said, sure, you can have it, but you have to find the last part of the funding. And then it just so happened that I met up with Klaus Rieser from Danish Technological Institute, that is now at Blue Ocean Robotics, and he said, why don't you do an industrial PhD, which is basically a funding program we have in Denmark where you're hired by a company to do your PhD work, and then the government basically co-funds about half of it. So it's a very lucrative program, basically.
Yeah. So the company provides half, the government provides half, and you do the work.
Yes, and then obviously you have to juggle being hired by a company at the same time as doing a PhD, which where the requirements may also be a little bit challenging. But now again, done a lot of experience in requirements handling. It was that's the deal, and it's a very good program. So, and that was basically it. I've worked with, it took about 4 years, finished my PhD, worked a couple of years more here as a consultant, and is now the team leader of the service robotics. So that's the short story.
Yeah, and the definition of service robotics, what's your definition? When you say you're team leader for service robotics, what kind of fields are you looking at for those robots?
It's the non-static ones. So
mobile platforms.
Mobile platforms in general. So yeah, mobile robots, AGVs, call them what you wish, drones, and potentially later on also underwater or surface vehicles. And the word service in that is professional service. It's a distinction we make. We are not very much into personal home care robots. I mean, it is something we may look into, but not at the moment anyway. So for us, probably counter a bit to the definition by the International Federation of Robotics. There are a lot of definitions out there. To us, a service robot is something that can be operated by unskilled personnel. And that's a major difference to other types of robots. But anyway, that's our working definition of it. It helps. It's you need to have some kind of explanation when you communicate with people, so you can explain what you're doing, because saying you do robotics is difficult, right? So you do service robotics, and people think they have a better idea of what you're doing, but then again, not really. So you always have to accompany it with something.
And the professional service robotics is it's used in a work environment, not in a home and private environment.
Yes, but then again. I mean, it depends, right? You could have a cleaning robot that is used for cleaning office buildings, a service robot, but what if someone brings that into your home and cleans your apartment? Is it then I don't know, we don't work very much with these definitions. Because it's,
could you, so now you've been doing this for a while, and I'm sure you've done many interesting projects. Could you give us an overview of some of the projects you've done and what you learned from them? What was the challenges and what you learned from those challenges?
Well, the basic idea of the Danish Technological Institute is to be a service institute, but for companies, for the industry and Danish society in general. So we're a non-profit organization doing both research and development, but also innovation to a large scale. So we are measured, our success is measured by how well we help the companies around us and the industry by taking knowledge from universities, collaborating with universities, generating new knowledge, research, and then bringing it into the real world and making it, say, operational. So what we do in service robotics is exactly the same, but with service robotics, that means our goal is to make service robotics operational, but bring them into use and do good for people, society, or companies.
And that you get from actual use, not test cases. And
No,
stuff.
exactly.
It has to be out there every day. It has to be out there, as you
Yes.
say, with non-PhD. What we usually
Yes.
talk about is PhD-ready robotics, where you buy the robot and you get a PhD student
That
with it.
makes very, very good sense, yes.
Yeah,
Indeed.
and we want to move away from that to the technology being so ready and so mature and intuitive and well designed that anybody can reasonably quickly learn how to use
Yeah.
it and employ it and in their business. This also applies to smaller businesses that today wants to start to use robotics.
Yeah.
They don't have the enormous resources that a larger company have. And they might not also have the size of the problem a large company have. I mean, they're not Audi that's supposed to build a line of cars for 20 years. They have a small problem, they have little time and resources, but they want to use robotics.
Yeah.
So what can you talk a little bit, you try to get them out there, you then have to have a partner in whatever industry you're working against. Can you talk about the relationship between you and that partner? How do you find them? Do they come to you and say, I would like to use robotics in my business, can you help me? Or are you going out there finding them, trying to apply the technology? Or can you talk about that?
Sure. There are several different ways of approaching this. Sometimes we are approached by a company has a specific problem. Sometimes it's, let's say, at a seminar venue where we hear someone talk about a problem that is unresolved and we spot it that way. Sometimes it's reading a scientific paper. It can come from a lot of angles, basically. But what has to be the key driver for getting it started is that we can see a business case both for the companies that are in it or for ourselves. Can we build up a service based on this that we can sell to a company afterwards? Usually we will have a Danish company, a partner in a project setup. I mean, if we take aside from pure commercial work, but do R&D setups, has to be a Danish company involved because that also helps the knowledge transfer and gives us a dedicated use case and business case. Otherwise, the company wouldn't be in the project.
No. Their participation is kind of a receipt on the fact that they, as a domain expert in whatever area,
Yes.
judge it to be likely that this could have a positive outcome, and that means you can believe in it and funders can believe in it, and it becomes easier.
Exactly. And it can be a technology provider. It can be a system integrator. It's the Danish partner. And of course, it can also be an end user. And sometimes it's all three, and sometimes it's just only one of them. It depends on the type of project.
And it doesn't matter which category they fall into.
No, and
as long as there's somebody there, that's okay.
It has to be a match, obviously, between the problem we're addressing, the partner constellation, of course, the funding program, and these things before you write a proposal. One that we have now in service robotics is with mobile industrial robots, MIR, making the Danish small mobile robot. So we are in a consortium with them and 26 other partners. It's a larger European project.
Yeah, coordinating that has to be very hard. Who's doing the coordination of that?
Well, it's actually a company linked to the Technical University of Braunschweig in Germany.
Yeah, I'm better than you, I would presume. That 26 different partners.
Yep, we hired in a project coordinator from there. So
that was smart. I'm thinking
it's a tough.
That was well spent money, I think.
Exactly.
26 different partners, and these partners come from all over the world, or is it Europe?
All over European projects, usually.
Yeah.
So we have quite a large distribution in that project as well. There's a different. It's not a project we're focusing on one case. There's several cases in a project like that. So typically there's a technology development part of the project, and then there's some kind of demonstration case project. And that's also where we collaborate with MIR on this one, is on the demonstration cases, because they want their robot used, obviously, in these demonstration cases. So in order, it's for the enabling part that we talked about a bit before. What we develop in the project is basically a box we call it's a modular link framework that we can attach to any, in parentheses, the MIR platform as a bit, because they're product partner, but in any type of mobile platform that we can plug in, and then we basically use the mobile platform for what it's good at, moving from A to B. But what's interesting is what happens at the ends of A and B. And the platforms are not necessarily enabled to do that. But our box can then make that easier. So that's a modular approach. So we basically enhance the capabilities of the platform. To that box, we can then add hooks or cameras, new types of sensors, and through a higher level skill engine we have, it's actually quite easy to program this as well. We can just drag and drop skills into the system, which makes it easy to do basically rapid prototyping. But using a mobile robot, it doesn't have to be rapid prototyping on a small scale. We're actually doing systems rapid prototyping.
Yeah.
So that's what the EU project has enabled us to do, develop this, say, box and a tool set of components, interaction components as well, that makes it possible for us to take existing platforms like the MIR and go into the industry when they call and say, oh, can you solve this problem? And say, we can basically take the robot, one arm, take the batteries out, otherwise it's too heavy, right? And we take the components in another, and then we go out and in a matter of hours, we can put up buttons on the wall, do the drag and drop and press play more or less, and do testing to see if it actually works.
And then just easily iterate quickly on that until it actually works.
Yes, so exactly, because sometimes you really just need to test it, because there are a lot of barriers and it's complex. Doing logistics, factory logistics in one factory with one robot is not the same as doing it in another factory necessarily. It's not just transferable. There are a lot of issues. Again, back to the system level design I looked at in my PhD back in the day as well.
You have to be very agile in this situation and quickly adapt, also because the factory you're in is probably going to change pretty quickly to adapt to its requirements. And then your robot has to be able to continue along, evolving together with that factory it's in.
It is. And that also, I mean, the paradox is that I'm a robotics engineer. We have a lot of robotics engineers around, and it's usually robotics engineers that do robotics. But truth of the fact is that when you move into the service robotics realm, we are really, really approaching the shared workspaces. It's not even up for discussion. Mobile robots, drone stuff are really, really close to people. And that creates a lot of new barriers, basically, right? There's even the ethical and moral ones. The robot can basically scare people by moving too close to them. It's able to. So how do you integrate these systems that invade your space into real world scenarios? And the horrible fact is here that if you look at all the factors that are required to do that, for example, knowledge of the organization that they're supposed to go in, and is the organization ready to adopt basically this technology, the workers, how will it actually interface and integrate with the workers? Are we substituting their job? Are we collaborating with them? The economy itself, is there a return on investment on this? And so on and so forth. The technology itself becomes quite small part.
It's all the other things around that has to be worked together.
And the engineers, the robotic engineers, are very, very good at the technology. And the rest is actually, and that's where we're shifting a little bit, needing a lot of new competences in this field, I believe, in order to really make the big breakthrough with service robotics. I mean, we need designers, we may even need anthropologists, we may need the softer sciences with good knowledge of technology as well, right, in order to break this barrier. Because when you look at a problem today, any type of problem, it could be cutting the grass, and you ask a robotics engineer, how will you cut the grass? You'll probably say using a robot, right? Without thinking, oh, there could be other ways, sure, but I'm in robotics, so I will solve the problem.
When you have a hammer, all the problem you own are nailed.
Exactly, so then it's not about solving the problem in the right way. It's about, you're already biased, right? But matter of the fact is, have you actually done the return on investment on a sheep? I mean, it might actually be more economical, it might last longer, et cetera, if it was actually about solving the problem. But that's not the business we're in. We're in robotics, that means we're in solving problems with robots. That's what we do, right? And that is biased already. And that's fine, we know that. If people call us up, they know we are...
They don't want a sheep because you don't sell those.
So that's why it's okay. But I think we should also remember that we are maybe not always doing the best solution that we are within robotics. Sure, for sure, there's nothing there, and you can always try to navigate and say maybe it's another approach that could be better. But we are robotics people. We do automation and we use these components.
But it's interesting that you're then bringing in that you're bringing in other groups of people to assure that this project is successful. And I think that that's something that we haven't seen enough of over the years. And also bringing in the end user more or less from the beginning, where you go to an area and say, we think that there's an opportunity to use robotics here, but we need your domain knowledge and expertise in what you do.
Yes.
But we also need to tell you, like you didn't in the first project, this is the limitation of robotics today when it comes to sensors, when it comes to actuators, when it comes to intelligence, which everybody talks about artificial intelligence today. And that, for many people, probably conjures up a robot behaving like a human being. And we're very, 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 very far away from that. So you as roboticist can advise the domain expert on what can robots achieve today and how can they do it. And they can tell you, of these capabilities, we would like to use this capability in this way. And then you can start to collaborate and work out how to be useful, basically.
Yes. And again, as what we do is try to bring this to market. So we are addressing research, but maybe not the, say, top 10, 15% of really high-level research going on. That's not the domain we're in, but we're taking the rest and trying to put that to use. For instance, the holy grail of mobile robotics has been the fully autonomous behavior for years, where realizing now after many, many years of working in these fields that maybe we should scale that down a little bit. Maybe we don't need the full autonomy. Maybe we can actually solve 80% of this really easily. We can do it now instead of blindly chasing the last 20%. And on top of that, we will keep the human in the loop and make the robot a colleague. That means you get higher acceptability from the workers, etc. So
and a better end result.
Exactly, and probably a better return on investment as well. But
especially since you actually deliver, because those last 20% are so hard, they will take many more decades to do.
Exactly.
So it's better we get the 80% of the profit now, and then we can make it 81% next year, and 82% the year after that.
Exactly, and that, because it's still difficult. I remember back in the days with the Manox project and the greenhouse robot, we actually had, we put white lines, broad plastic lines on the ground, we put down with big nails. SLAM was not really invented at the time, but it would have been possible to navigate other ways. But the lines, though cluttering up the environment, made it easy for people to see where it was going. So, that gave a sense of security and safety, because, if I were at a white line, there's a robot coming, it would move a little bit on a very angular path. It looked a bit silly, which was fine. We discovered people were laughing at it. Great, then don't feel threatened by this robot. So there are actually a lot of benefits from doing it this way. We had one obstacle though, we had several obviously, but following a wide line, which was basically textbook page 1 for robotic line following. Very easy. You just do that. We did it in the courses back in the day with the remote control cars. Yes. Fine, but they don't teach you about the changing light conditions, the low-hanging sun in the late summer evenings, right? That goes underneath, creates reflections, driving on dry concrete, on wet concrete, the color changes, and making it robust. So we actually talked to a lot of people back in the day from university about helping us solve this problem. Can you find a white line in this picture? And it was really, really difficult. And at that time, you also realized, okay, we did this and that vision course at university. We did all this motion planning algorithms and stuff, but even the basic stuff we can't really solve in the real world. And a lot of times it's of course about redefining the problem and maybe not solving exactly that, but moving the goalposts, resolving the problem sometimes. And that's, I think, is the big art that engineers, robotics engineers actually are into. They want to make solutions that work. That's about that type of, just call it creativity as well, of making solutions. Because you have all these building blocks. Sure, you have advanced mobile technology or robotic arms, but how do you create the solutions? When you don't really know the environment, you don't really know the tasks, the people that are in there, and to create a return on investment.
That's very challenging, and that is robotics.
Yes.
What we're talking about is, as opposed to software or something else, that is the core of the problem in robotics, but it's also why we like it, because it is hard, but not so hard we can't solve it in the end. We'll just have to reach 80% of a good solution and then try to make it 1% better every year.
Yep.
Can you talk about some different projects that you built and that are now out there in the operating?
We don't have projects out there operating and doing, because in the projects we don't do product development. We do technological development that we then afterwards take and put into use. So we used, especially from the R5 Corp project, we've taken the framework and the whole co-working platform that was also developed through a lot of other EU projects in the manipulator domain. We did test case, for example, at Arla, the dairy producer, which you also have in Sweden, so originally a Swedish company, I guess, and they all merged up. And together we did an extra project, a different one, where we were testing the Mir robot in their production for order picking. Basically seeing, to aid the workers that today, because we've gone from the series production to order production, the batches become smaller and smaller, and you don't need AGVs that can tow 5 tons, but maybe only one that can tow 300 kilos. So Mir platforms and the like of them are very interesting. So we were testing that in a small project, basically using technology from the EU project. And to even make full circle, the examples we did with Arla and the results we achieved there, we did some test runs. We didn't make a solution for them, but we got a lot of experience, tested a lot of stuff, that we can then feed back into the EU project and do an additional case in the EU project, basically saying, okay, if we enhance these and these parameters. So that's more or less the way that we're testing it. We have clients now where we're taking it out on a commercial basis, but a lot of times it's more for the prototyping part, and a lot of it is for internal use. So we may or may not use it directly in commercial products, but it still helps us reach surety about the market and then the solution, the potential of it, basically.
You've been in robotics now for quite some time, and you've seen a lot of what's going on here and there all over the field, not outside your own field. Could you talk a little bit about where you think robotics is going, and where do you think we're going to see big breakthroughs in the coming years, because that area is mature? Like, for instance, vacuum cleaners. They were impossible, and then suddenly they were everywhere, and now they're just a standard product, right? Of course, it's improving with every generation, but it's a very big difference from having a robotic vacuum cleaner to having a slightly better one. Where do you see progress coming in the coming years for robotics?
I think the biggest advance there will be, hopefully, is not actually in the technology field. It's within safety and standards. It's key, because we're at a crossroad these days where we have technology now, not just university level work. We actually have products that do work, they're ready to be pushed into the market. The problem is when you add any little thing to it, it needs to be CE marked again, or risk assessments have to be done. Standards are not in place, they are being worked on, it's work in progress, but who can do this? It's the same kind of barrier that is with the trucks, the autonomous trucks around, and autonomous cars. Sure, they've been in the media, they've been shown, but still the train system we had through Europe a couple of months ago now had an escort. And there's a reason for that. There's nowhere near soon will this happen in the real world until we have solved some of the safety issues. Which of course is everyone, except that safety is the paramount thing we have to accomplish. It is. Without that, we don't have a product. Nope, we don't. And that's really a killer for a lot of this progress, unfortunately. And there are initiatives out there. We started one now, another huge 30-partner project called SafeCop, where we're also doing some testing in the project with Danish partner. But actually, the big guidelines of the projects, the premise is safety certifying heterogeneous systems. So when you take two components that are not CE marked, well, both CE marked, and you put them together, how do you CE mark this? Back to your part with the modularity. oh, modularity is wonderful, except that every time you change the module, you have a different product and it's not safety certified. So there's a lot of obstacles. If you transfer that to the driverless cars, well, that's actually a modular system being when they approach each other that connect. So it's a virtual connection. How do you safety certify that? We're looking at, other products are looking at it as well, but it's really, it's a tough nut to crack. So I think it will be a very important thing to solve, and I hope it will be in the next years, because a lot of people are realizing this is really important, and we do need to solve it and address it, otherwise we are at a standstill. Vacuum cleaners, sure, they are allowed to drive around because they don't do any harm, but even if you take 100 kilo mobile robot that drives in a factory, well, if you attach a trolley to that and it bumps into someone, well, it's really a real hazard. Even if there's lazy safety scanners around, I mean, can you guarantee that this is safe?
Yeah, the safety is very challenging, because most of the danger cases is going to be very, very uncommon and rare. And how do you test to find them? How do you evaluate the platform to find these risks?
Statistics at the end, right? I mean, what's the probability that this will happen is low, and as I also read some time ago, we will at some point eventually have to get used to headlines in the newspapers where it says like 2 people killed by driverless car.
Of course, because we can't, and what we have to remember here is that if a driverless car kills half as many people as a driver, person-driven car, it's still better, especially for the half of the people that are still alive.
I think this, hopefully, I really hope that this will be one of the advances, that we will see things moving also more easily into the market, because again, we have a huge interest in that, making more complex applications in more complex scenarios. And before we know more about this area, it's very hard. We can dream up stuff, do research and development projects, and set research goals high above, but we don't create much value doing that.
No, and this is also a need where we as a robotics community have to start to work with regulatory authorities early on. I think, for instance, drones, the people active in the drone community could have interacted earlier with the regulatory authorities and avoided some delays and avoided uncertainty.
But it's also there's a lot of things happening around. We're a part of the standardization groups on the civil drone use as well. And there's a lot of things happening, and all across Europe, probably across the world in this, and there's no real alignment. There will be something on a European level as well, and it's another area obviously where a lot of things will happen. And yes, as long as you fly in an open field far away from people, you can see the drone, you can do whatever you want. But usually people want to fly around with this people, buildings and other stuff, and it's just not trivial. Well, today you can get dispensations, you have to call the police and tell exactly what you're doing, you have to do manuals, write down exactly where you've been at what time, and then you can do it.
But that also limits the application we can use it for, because it pushes cost and pushes complexity.
Yeah. But it's a new world, right? And I think we talked about earlier, also before this interview, was the press handling, the way that robotics are communicated in general in the press, which has for a lot of years also given movies, Hollywood, other things, put some kind of level of expectation, so to say, on a lot of roboticists. And roboticists have... everyone has been complaining, saying, "No, we can't do that." Sometimes, and stories like that the reality is often more surprising than the fiction. We've tried a lot of stunts to try and make up for it, but the truth of it is also that then when we do something that is spectacular, we do like the press to be there, and do like them to tell the nice stories about what we're doing, and it still keeps tilting the picture a little bit, right? Because now the media is full of autonomous cars and drones everywhere and humanoid robots and all this stuff. So
general artificial intelligence.
Yes, and it's partly our own fault. It's not just the media. We also helped hype this, because every time we do a new project and we have come close to something, we will also tell the story, right? That this and that, and then that's what people hear, and the expectations change, and they don't expect, I accept that we don't have walking robots, or what's the problem with autonomous cars and these things, and I'm sorry that with the ISO, it doesn't sell that well to the public and to the media, and say, but we do need them to be safe. Yes, it's paramount. We need them to be safe.
And also this is also something that can be challenging for somebody in a company that wants to reach out to you and do a project together. That is to determine what's hard and what's easy in robotics. It's not intuitive in all cases that this is really, really hard and we're decades away from doing it, or something else might be reasonably easy to accomplish. But I think that what you're doing here at the center, combining research, productization and bringing it to market is what we need. And then I presume that anybody in Denmark can reach, or anybody over the world can reach out to you and collaborate on a project with you, right?
Absolutely. We're very open to that. Again, what we need out of it is something that afterwards, we're not selling products, but we're selling then the knowledge, and it should then benefit. We should take something that we can use in a broader context. It's not a humanitarian organization, but it's still the premise of what we do.
But we can just encourage people to reach out and to create more cool robotics projects together.
Yeah, because no one has all the answers.
No, we really need to cooperate on these things.
We do, and we can say that experience in the field and also have high knowledge of the state-of-the-art research results does actually help when you build the actual lower-level systems, because you do need to know both the pitfalls and what is possible and what is not. But we will see more of the useful service robotics out there in quite soon as well, because we started picking off the low-hanging fruits instead of chasing the pot of gold at the end of the rainbow. And then we will slowly, like they're also doing with the drones, then we will also slowly push legislations, we will help standardization, instead of saying, we want everything to be autonomous. We have the self-driving cars doing that level, and meanwhile we're trying to push a bit from the bottom, so to speak, because there's so many domains that could use robots. There's so many tasks that could be applied for that it's just it's a matter of getting started and getting the right collaborating partners together.
Perfect. So we'll just encourage everybody to reach out and build cool robots together with you.
Exactly.
Thank you very much for taking the time to do an interview. It was a pleasure speaking to you.
You too, Ben. Thank you.
I hope you liked this episode of Robots in Depth. I'm proud to produce Robots in Depth with the support of the sponsors, Carbon Robotics and Aptomica. Carbon Robotics is redefining the relationship between humans and machines by making advanced automation dramatically more accessible, with low-cost robotic arms, integrated vision, and a powerful task intelligence engine that automates tasks no human was born to do. Carbon Robotics is proud to support Robots in Depth in their goal to elevate the global robotics ecosystem. Aptomica rents anything in modular robotics. Dream, rent, build. Visit aptomica.com to connect. If you like this episode, tell your friends, give us a thumbs up, subscribe and turn on your notifications. I am Per Sherboy, and I'll see you next week in another episode of Robots in Depth.